Hi everyone, welcome to Pre-Calc. We're going to be beginning with chapter 2, which is on functions. Our very first notes are on interval notation. I want to start off with some review. I want to just look at some vocabulary terms. To begin, a set is a collection of objects whose contents can be clearly determined. The objects within a set are called elements. We can use sets to describe solutions to inequalities, to equations, things like that. We use set builder notation using these curly brackets to list all of the elements in the set, such as the set A, which has elements 1, 2, and 3. Graphically, we would show this as the set of elements by placing a dot at the correct location for each of the elements on the number line, increasing from left to right. So if I have my number line here and I would call the center 0, we can plot 1, 2, and 3 as just the single points on that number line. So there are only 3 elements in this set, so there are only 3 dots on our number line. If we want to express an infinite number of solutions or an infinitely sized set, then we can use our inequalities, greater than or less than, greater than or equal to, or less than or equal to, uh, as an element. We would write this using our curly brackets, the set of x, the real numbers x, such that x is less than 1. So that colon, that you can also write that as a vertical line, represents such that. So we're saying a condition for x for which the set or solution is true. Graphically, we consider the entire span or interval of numbers rather than just a set of individual values. So we shade. We use an arrow to indicate the direction and indicate all of the numerical values in that interval to the left or to the right in the positive or the negative direction of that key value. What we're learning today is called interval notation, which is just another way of expressing a set. Okay, but we're going to express it in, I think, a more concise or more compact form. Interval notation represents a shaded span of the numbers on the number line by showing the numbers at the ends of the interval, and we separate them with a comma. Now we show whether or not we want to include those key points, those key values, using either parentheses or square brackets. If we use parentheses, we're indicating that the endpoints are not included in the interval or the solution set. When graphing, these would be like our open circles. Whenever we're talking about an infinite set, then we are talking about infinity. We always use parentheses to surround both positive and negative infinity. We use brackets when we want to describe endpoints that are included in the interval. So when we're graphing on a number line, this would be like our closed circles or our solid circles. So let's take a look at a few examples. I want to solve the inequality x plus 3 is greater than 5, and we're going to express our solution using the set builder notation. So to solve this inequality, I'm going to subtract 3 from both sides, and I get the solution x is greater than 2. Okay, so using set builder notation, remember we use our curly brackets. We're going to say x, the set x, such that x is greater than 2. Okay, so we're saying all real numbers x such that it follows this condition that x is greater than 2. If I wanted to graph this on a number line, I'm going to plot my 0, and we want to get all x greater than 2. So I'm going to plot 1, and plot 2, I'll even plot 3. Our key value here is 2, and we're just looking at x greater than 2, but not equal to. So we're going to indicate this using an open circle and shade everything to the right, everything greater than. Don't forget your arrowheads. This extends infinitely in the positive x direction. To write our solution as using interval notation, we're going to take our key values or our endpoints of the interval. Well, the left-hand endpoint is 2. And the right-hand endpoint, well, it just goes on forever and ever. So this, our right-hand side is going to be infinity. It goes on forever. Now we have to figure out whether we're using parentheses or square brackets. So looking at this inequality or the graph, do we want to include 2 in our interval? No, we do not. So we're going to use parentheses. Likewise, for infinity, we know that we use parentheses always for infinity and negative infinity. So using interval notation, we have from 2 to infinity. And notice this is not an ordered pair, x comma y, or a coordinate on the coordinate plane. This is representing an interval for which x is a solution to this inequality. Okay? So let's take a look at all of the examples that we can have in interval notation. The first is an open interval, and that's if both of the endpoints are not included in the set. So this would be the compound inequality without these or equal to's. On the graph, these would be like our open circles on A and B. A closed interval, we do want to include those endpoints. So here's our square brackets. These are less than or equal to's. We've got that or equal to piece. And these would be our closed circles on the graph. We can also have half open and half closed. So the next two examples, if the lower bound is included, then we use a square bracket, and the upper bound is not included, we use parentheses. Likewise, we have an or equal to for the lower bound, but not for the upper bound. Graphically, we see this as a closed circle moving toward an open circle from left to right, and vice versa for the other way around. An infinite interval we just saw is if it starts at that key value and then just continues onward in either direction. So if it's going to positive infinity, we've got our arrow going to the right, and our right-hand bound is infinity. And we always use parentheses around infinities. If we want to include that first point, then we're going to use a square bracket, and if we don't, we use parentheses. Likewise, if the interval is less than, then we're doing everything to the left of that key value. We're going to use, again, parentheses to surround our negative infinity, and then a square bracket to include that right-hand bound or that upper bound. Okay? And finally, the infinite interval is just all real numbers. So this is every number that, every real number. Okay, and we represent this x such that x is just a real number, and then it's literally just the number line, every number on the number line. Okay, let's get some practice. I'll try a few on, we'll try a few together, and then I'll have you try a few on your own. So number one, let's go ahead and write this using both set builder notation and interval notation. So the first one, I'm looking at this using set builder notation. We have x such that x is not including, so we're just looking at all the values to the right. So just greater than, strictly greater than 2. Using interval notation, we're going to go from 2 to infinity, and we don't want to include 2, and infinity always has parentheses. This example was from earlier. For number 2, we can write this using a compound inequality. So we have our set builder notation, that curly bracket, x such that x is greater than 0, greater than or equal to 0. So we want to include 0, but less than 3. So we can write this compound inequality. Double check that your inequalities make sense with that graph. If you have a closed circle, you want that or equal to on that bound. And then if it's an open circle, you do not have that or equal to. Using interval notation, we know that both the left-hand and right-hand bounds are 0 and 3 respectively. And do we want to include both of these? Well, we only want to include 0. So I'm actually going to change that real quick to a square bracket. So this indicates that 0 is included, but 3 is not. When you have more than one interval that's a solution, you can use this mathematical symbol called a union. And that means that we're taking two sets and we're combining them. So using set builder notation, again, that curly bracket, we have x such that x is, we're looking at all the values to the left of positive 5 and including. So we have x is less than or equal to 5. And then we also want to consider all of the values greater than 7. So we're going to write or x is greater than 7. So verbally, this mathematical symbol union is synonymous with the word or when we're talking about inequalities. But when we're using interval notation, we have to use this symbol here, this union symbol. So to write x is less than or equal to 5, we're going to say from negative infinity to positive 5 and including 5. Now we also want to consider the other set. So we're going to say union x greater than 7. So that's going to be from 7 to infinity, and we're not including 7. So this is our answer in interval notation. All right. Go ahead and flip the page. The instructions, unfortunately, are up here. Write the following inequalities in interval notation and then graph it. So I'm going to write x is less than or equal to 3 in interval notation. I know that we're looking at everything less than 3. So I'm going to go from negative infinity to 3. Negative infinity always has a parentheses. 3 we want to include, so that's going to be a square bracket. I'm going to graph this by putting 0 in the center, and I'm going to count up 1, 2, 3. I want everything to the left-hand side of that, and including 3. So we have a closed circle on 3, and shading to the left. I'll do one more, and then you can try a few on your own. Number 5, here we have x is between negative 2 and 4, not including negative 2, but including 4. So our upper and lower bounds are 4 and negative 2, respectively. And we don't want to include negative 2, but we do want to include 4. To graph this, we'll start at 0, count backwards to negative 2, and count upwards to 4. I don't want to include negative 2, so I'm going to use an open circle there. And I do want to include 4, so I'm going to use a closed circle there. Our solution set is all of the x values in between, so I'm going to connect those two circles. All right. Go ahead and try numbers 6, 7, 8, and 9 on your own. You can pause the video, and once you've completed them, go ahead and unpause the video to check your work. All right, so let's take a look here. I forgot to write my interval. So number 5, we have from negative 2 to 4. Number 6, we have from 3 to 8, and those are both included, so we got those square brackets. For number 7, we're going for x greater than negative 4, so from negative 4 to infinity, not including either. X less than negative 3, we have negative infinity to 3, not including. And then we have a compound inequality, so from negative 1 to 5, we don't want to include negative 1, but we do want to include 5. And then we've got this union of from 6 to infinity, and we do want to include 6. Take a look at the graphs as well to check your work. All right, let's try a few more. So number 10, now we want to write this using set builder notation. So I'm going to write the interval from 2 to 8 as the set of x, such that x is between 2 and 8. So 2 is less than x is less than 8. We do not want to include those because these are parentheses, so I'm going to just strictly do less than. For number 11, we have negative 5 and 0, so we have the set of x such that x is between negative 5 and 0. And now I have to check, do I want to include either of those? I do want to include the negative 5, so I'm going to put a or equal to. All right. One more time, go ahead and pause the video, try numbers 12, 13, and 14, and then unpause to check your work. All right, so take a look at these answers, check your work. Did you get them all right? We're going to get a whole lot of practice on this in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.